Hello everyone, welcome to my channel. This is Karuna, teaching the course Computer Architecture and Organization. Fifth unit contains the following topics, out of which we are concentrating on basic memory circuits. In this part 2 video, static RAM cell. This is the structure of the memory cell, which consists two inverters and two transistors, which are connected to a word line. This word line is connected to address decoder. Inverter. The input of the inverter is 1, then output of the inverter is 0. Memories that consist of circuits capable of retaining their state as long as power is applied are known as static memories. So this SRAM, this is static RAM, consists two inverters are cross connected to form a latch. The latch is connected to two bit lines, bit B and B dash bit, by transistors T1, T2. These transistors acts as a switches that can be opened or closed under the control of word line. When this word line is activated, then transistor T1 and T2 will become on. When this word line is at ground level, the transistors are turned off. That means the latch retains its state. Let us assume this is the memory cell is in state 1. For example, if the logic value at x is 1 and y at 0, because input of the inverter gate is 1, then output of the inverter gate is 0, then again this 0 will fed to this second inverter, then output of this second inverter becomes 1. Okay, so this state is maintained as long as signal on the word line is at ground level. Suppose processor wants to get the bit 1 from this cell, then this bit will be transferred to the processor through B line. Suppose processor wants to get the 0, then this 0 bit will be transferred to the processor through B dash. When transistors on, these two transistors are on when word line is active. Let us see. Read operation. In order to read the state of the SRAM cell, the word line is activated. To close switches T1 and T2. If the cell is at state 1, the signal on bit line B is high. If the cell is at state 0, B dash is low. Otherwise, if the cell is at 0 state, then B and B dash are complements of each other. If it is 0, then output of inverter is 1. Okay, so that's what we can say, B and B bar are complements of each other. So sense and write circuit connected at the end of this bit lines to set the output accordingly. Okay, during write operation, the state of cell is set by placing the appropriate value on bit line B and its complement on B bar, and then activating the word line. This forces the cell into corresponding state. The required signals on the bit lines B and B dash are generated by the sense and write circuit. These static RAMs are fast, but they come at high cost because their cells require several transistors. To reduce the cost, we can go for dynamic RAMs. However, these cells do not retain their state indefinitely. Information is stored in a dynamic memory cell in the form of a charge on a capacitor. The cell consists of a capacitor and transistor T, which is connected to word line and bit line. In order to store information in this cell, the transistor on and an appropriate voltage is applied to bit line. This causes a known amount of charge to be stored in the capacitor. After the transistor is off, the capacitor begins to discharge. The information stored in the cell can be retrieved correctly only if it is read before the charge on the capacitor drops below some threshold value. During read operation, the transistor T in a selected cell is on. A sense amplifier connected to bit line detects whether the charge is stored on the capacitor is above the threshold. For example, capacitor charging, discharging, charging, discharging, charging, discharging. Capacitor voltage. Okay, so if you take this is threshold level. Okay, the T in a selected cell is on. A sense amplifier connected to the bit line detects whether the charge stored on the capacitor is above the threshold value. If it is above threshold value, it drives the bit line to a full voltage that represents logic 1. Okay, if that voltage is above this threshold, then that is represented as logic 1. If the sense circuit or sense amplifier detects that charge on the capacitor is below the threshold value, it pulls the bit line to ground level. That means capacitor has no charge, which ensures capacitor has no charge. That represents logic value 0. Likewise, required bits are stored in that memory location that can be read or write with the help of sense or write circuit. Okay, in this case, static RAM cell, continuous power is needed for the cell to retain its state. If power is interrupted, the cell's contents will be lost. Hence, SRAMs are said to be volatile memories because their contents are lost when power is interrupted. Now, let us see the asynchronous DRAM's internal structure of 2M into 8 dynamic memory chip. Okay, this is the internal organization of 2M into 8 dynamic memory chips. Okay, 2M means 2 mega locations. Each location stores 8 bits. 8 represents data. 2M represents memory locations. So we can say 2MB. B means byte. So 2M into 8. 2 into 8 is 16. 16 mega cells are required for this organization. Okay, so here 2M locations, 8 bits. Nothing but 16 mega cells are required. Each cell stores 1 bit. Each memory location consists 8 cells to store 8 bits. See, 2M into 8 can write it as 16M cells. Okay, and also it can be represented as 4K into 4K cells. K means kilo. Okay, M means mega. Okay, so kilo having 3 zeros, mega having 6 zeros. Okay, so here 3 plus 3, 6 zeros. Okay, we can write 16M in terms of K. 4K into 4K means 4096 Okay, so here these cells 4K into 4K cells can be organized like this: 4K rows, 4K columns. Okay, so 4K column cells in row are divided into 512 groups of 8, means 512 groups. Okay, 512 into 8 becomes 4096. We can say 4096 cells divided into 512 groups. Each group consists 8 cells, means can store 8 bits. So first 4K indicates rows. Here this organization consists row address latch, row decoder, column address latch, column decoder. Each column connected to sensor write circuit with the help of control signals, CS and read or write bar coming from control unit. Okay, this can be reorganized as 4K into 4K, means 4096 rows and 4096 columns. Again, these columns are divided into 512 groups. Each group consists 8 bits. See, 4096 rows. To identify any row, we require 12 address lines. See, for this size of memory, 12 address lines are required. Okay, so 2 power 12 equal to 4096. Okay, so to identify the rows, 12 address lines are required. If you want to select first row, you need to send first 12 0 bits. If you want to select last row, you need to send all 12 bits are ones. Like that, you can select any row out of 4096 rows with the help of 12 address bits. And to point to mega locations, we require 21 address lines. Okay, so these 21 address lines are divided into 12 address lines and 9 address lines. Okay, so first 12 address lines are used to identify the row. Next 9 address lines are required to identify the column. Any column you can select from 512 columns. So 512 groups of 8 bits. Okay, each group consists 8 cells which can store 8 bits. Okay, you can get any 8 bits from that row with the help of this 9 address lines from 512 groups. Coming to our diagram, 0 to 20 address lines are used to identify 2 mega locations. Okay, so here 2 mega locations into 8 cells are reorganized into 4K into 4K, 4096 rows and 4096 columns. Again, these columns are divided into 512 groups. Each group consists 8 cells, means can store 8 bits, nothing but 1 byte, means each row can store 512 bytes. Okay, so this is byte, 512 bytes. To select rows, row address latch and row decoder are used. 9 to 20, these higher order bits, 12 address lines are used to identify 4K rows. The rest of the 9 address lines are used to identify 512 column groups. Hence, 21, 0 to 20, 21 bit address is needed to access a byte in this memory. To reduce the number of pins, the row and column address lines are multiplexed on 12 pins. Okay, it can be reduced to 12 pins from 21. Let us see how it can be reduced. See, A0 to A8 9 address lines are used to point the column. Next, 9 lines, here 0 to 8 lines can be multiplexed with A9 to A17 address lines. The same 9 lines can be used to transfer address of the column in one time, and same address lines can be used to transfer row address in another time. Okay, so that's what these two lines can be multiplexed. Transmit 9 address bits. Okay, rest of the address lines 18 to 20 means 3. Okay, so this 9 plus 3 equal to 12 address lines. Okay, so with the help of this multiplexing, we can use 12 address lines to point both row and column instead of 21 address lines. Okay, so that complexity may be reduced, cost also can be reduced. Let us see how it performs read and write operation. The row address is applied first. It is loaded into the row address latch in response to a signal pulse on the row address strobe. This is row address strobe input of the chip. Then a read operation is initiated in which all cells on the selected row are read and refreshed. Shortly after row address is loaded, the column address is applied to the address pins and loaded into the column address latch under the control of column address strobe signal. The information in this latch is decoded and the appropriate group of sense or write circuits are selected. If read operation, the output values of the selected circuits are transferred to the data lines D0 to D7. For write operation, information on the D0 to D7 lines is transferred to the selected circuits. Here row address strobe, column address strobes having bars, nothing but active low signals. The timing of the memory unit is controlled by a specialized unit which generates RAS and CAS. Those are not synchronized with the clock signal. That's what this memory is called asynchronous DRAM. Okay, many DRAM chips incorporate a refresh facility within the chips. So advantage of this is high density and low cost. Coming to the fast page mode. Suppose if you want to access the consecutive bytes in the selected row, this can be done without having to reselect the row. That means add a latch at the output of the sense circuits in each row. All the latches are loaded when the row is selected. Different column addresses can be applied to select and place different bytes on the data lines. Okay, so consecutive sequence of column addresses can be applied under the control signal CAS column address strobe without reselecting the row, which allows a block of data to be transferred at a much faster rate than random accesses. Block of data means a small collection or group of bytes is referred as a block. Okay, so this block of data transferred at a faster rate referred to as the fast page mode feature. Let us see the difference between static RAMs and dynamic RAMs. Static RAMs, which consist circuits that are capable of retaining their state as long as the power is applied. That's what we can say, these RAMs are volatile memories because their contents are lost when power is off. Access times of static RAMs are in the range of few nanoseconds. However, cost is high. Coming to the dynamic RAMs, do not retain their state indefinitely. and contents must be periodically refreshed. And also, contents may be refreshed while accessing them for reading. That is about difference between SRAMs and DRAMs. Thank you. We will meet in next video.